Hi everyone, welcome to this lesson on chemical bonding. This lesson will be good for both my Year 9s and my Year 10s. The types of bonding that we're going to cover are going to be ionic bonding and covalent bonding. These will need to be known for both Year 9s and Year 10s, although covalent bonding we don't go into a great amount of detail. And for Year 10s only, you'll need to know about metallic bonding as well. Now, for ionic bonding, this is a type of bond which occurs between a metal and a non-metal atom. Now, what happens for an ionic bond to form is that a non-metal atom will attract an electron away from a metallic atom. The reason it does this is because both the non-metal and the metal want to form a full outer shell, and to have that full outer shell, they need 8 electrons. In the case of the metal, it's easier for them to give away an electron, and in the case of the non-metal, it's easier for them to attract extra electrons in order to get to the 8 in the outer shell. Now, when this occurs, that there is this transfer of electrons, both these atoms will form ions and obtain full outer shells. The metal forming a cation, which is positively charged, and the non-metal forming an anion, which is negatively charged. Now, once both these atoms form ions, there are strong electrostatic charges that hold the bond together and make this a very strong bond. Now, here I've got an illustration of 2 atoms. One on the left is sodium with its 11 electrons, and on the right we have chlorine with its 17. Now, hopefully you could see from here that sodium just has 1 electron in the outer shell, whereas chlorine would like that electron to make its outer shell have 8 electrons. So just what happens is that the 1 stray electron from sodium will be pulled along and join the outer shell of chlorine. Now, if we do a new count, we actually have formed 2 ions. The sodium ion now has 10 electrons in total, and with 1 fewer electron, it now has formed a sodium 1+ ion, whereas the chlorine now has 1 extra electron from the sodium. It now has a total of 18 electrons and has formed a chlorine 1- ion. Now, covalent bonding is a little bit different. Because covalent bonding is a bond between 2 non-metal atoms, both these atoms are going to want to keep their electrons and then want to gain electrons from other atoms. So that being the case, they sort of take the democratic view and they decide that they're going to share. So each non-metal electron will give 1 electron to each other in order to share, and that shares pair of electrons forms a covalent bond. Now, any electrons that are shared contribute to both atoms when it comes to filling their outer shell. So if you come to counting electrons for the outer shell of a covalent bond, which you won't have to do this year, probably next year, you'll find that they count for both, and so they're shared and form a nice strong bond. So here's the simplest covalent bond that I could find, which is hydrogen with itself to form a hydrogen molecule. Each hydrogen, as you know, has only a single electron. So you'll find that the hydrogen on the left gives 1 electron, and the hydrogen on the right gives electron as well. So each are giving 1 electron in order to form this new bond. So now these 2 atoms will come together and form a nice covalent bond. Now together, they are now forming a hydrogen molecule which has the formula of H2. Now, sometimes covalent bonds can happen more than once between 2 non-metal atoms. Also, a particular non-metal atom may form multiple covalent bonds, but again, this is delving more into a Year 11 territory. Now, Year 9s you can probably shut off at this point, but Year 10s you'll need to learn about metallic bonding. So metallic bonding, as the name suggests, is between metal atoms. These can either be the same type of metal, such as in a piece of copper, it is full of copper atoms and they're all bonded together with metallic bonding, or it can be in an alloy where you've got 2 or more different types of metals bonded together. Now, the metal atoms are arranged in a rigid lattice formation. Now, because these metals are actually not wanting to keep any of the electrons, but no one's willing to accept them either, the electrons that exist in the valence shells of these metal atoms are delocalized, which means that they're free to move around the metal atom lattice, and they form what's known as a sea of electrons. Now, the fact that these electrons are free to move allow for the specific properties of metal substances. So such things as being able to conduct heat and electricity is completely as a result of this unique type of bonding. Now here what we've got is we've got the yellow spheres, which represent our particular atoms. So let's say it's going to be copper. All the copper atoms are lined up, and what they will do is they will donate their electrons to the whole piece of metal. So they'll get rid of whatever valence electrons they have, and when they do that, they of course form cations. So what you're left with is a lattice full of copper cations, and the little blue spheres are representing the electrons that they've discarded, but of course they can't really go anywhere, so what they do is they sort of float around the lattice and become delocalized. So they don't belong to any one atom, they belong to all of them at the same time, and that they allow for the metal to be a metal being able to be shiny, ductile, malleable, conduct heat and conduct electricity. So I hope that clears you up for everybody, all this stuff about bonding. Please let me know in the comments below or just send me an email if you want to know anything else, and good luck on your test.